Good day, my wonderful viewers. So welcome once again to Frequency Online Math. So today we'll be talking about continuous random variable. So let me refresh your mind on random variable. We earlier stated that random variable is just assigning a letter X. Some people can still use Y to the outcome of a sample space. And I told you that we have two types of random variable. That's district and continuous. Under district, that district is what countable. While this continuous random variable is not what countable, is what uncountable. So, and I told you that district random variable is associated with PMF, that's probability mass function, whereas the continuous is associated with PDF, which is what probability density function. And we have this thing, district probability distributions. We have Bernoulli under the districts. We have Bernoulli, we have binomial, we have geometric, we have hypergeometric, we have Poisson, right? So we'll be talking about continuous random variable. So what is this continuous random variable? Continuous random variable is one which takes an infinite number of possible values. Continuous random variables are usually measurements. Example include height, weight, the amount of sugar in an orange, the time required to run a mile. So when you hear about infinite, it means ad infinitum. It does not end. So the PDF of this that's PDF probability density function of continuous random variable is given as probability of A that X is was greater than you can still put it X is greater than or equals to A and X is less than or equals to B. You can still put it like this. So X is greater than or equals to what A and X is less than or equals to what B. So you can still say A is less than or equals to X and X is less than or equals to B. Is given as what integral from A to B. That's lower limit and upper limit f of x what the x. The characteristics of the probability density function that f of x must be greater than 0 for all x. So let me represent this thing. You know that in this continuous random variable, here is our what f of x. Are you there? So if we have a curve like this, if we have a curve like this, you know that this place, this is the height of this curve. So, for example, I want to calculate the area under this curve, the area from A to B. This is our x. So, okay, let me first of all explain that our f of x must be greater than what 0. So, our f of x must be greater than 0. You can never see this curve. This curve must be what greater than what 0. So, from 0 up, you cannot see this curve to be what down. You understand? So f of x must be greater than or equals to what 0. So it must start from where this origin 0. So you cannot see it to be what down. So for all x. So we also have that okay. I use minus infinity. Let me use our a, the boundary for a, b. So you know that if you want to find the area under this curve, the area under this curve, if you want to find it, it will be what integral from this a to this b, that's under this curve or this place a and b, from this a to this b of what f of x, the x. That's if you want to find the area under this curve. So that's this continuous random variable. Now they are just trying to tell us that the area under this curve a and b must be equal to what 1. So it must be equal to what 1, the area under what this curve. So that's what he's trying to tell us. So and again, um, this our h, this our h is the distance from this our x to this what point. That's these 2 points. This h is the distance, which is called the what f of what x. So this h is the distance, which is the f of x. So and the f of x is also called the PDF, that's probability what density function. So in our next video, we'll be telling you types of this continuous random variable. So we have the types. We have normal and standard number. So we talking about normal and standard number in our next video. Thank you for watching and God bless you. Bye bye.